why I said it. Only you.
Wait, is Miko there?
No. No.
Bro, I'm not gonna eat that. I don't know where you. It's all smushed. Thank you. Thank you. Stupid cat. Peter, your house is like. It's like far. So far. Okay, I'll come drop it off for you. You owe me a crisp. You owe me a crisp high five.
I owe you a what?
He owes. He said. Yes. I told him he owes me a crisp high five.
Okay, crisp high five.
It's a crisp high five.
Okay.
It's just a nice high five. That's it. It's like a crisp dollar bill. It's like a brand new nice dollar bill. Oh, Peter, did I tell you my mom knows what sheesh is?
Really?
Do you hear her?
No.
Good.
Is she
Because
actually going? Sheesh.
yeah, no, that's my mom's going she.
Really funny.
No, it isn't. It's terrifying. It is
It's
horrific.
hilarious.
It is boomer tech. Can we switch? You take her, I take your mom. It's a win-win. Do you hear the puppet? He's just on the floor behind me. I don't trust him. He's going near the outlet. Oh, he's licking it.
He's licking
Yeah.
it.
Oh, he's getting electrocuted.
Hope he
Oh,
comes
oh.
in to say hi for you before you leave. What?
I think I
I will.
said he's licking the outlet.
Where's going to? Oh, she's not coming in here.
Yo, Peter, she's putting the spicy ones separately.
Okay.
I won't tell you which bag is which.
Oh
Let me
no.
watch you suck it.
I'm gonna assume the redder ones are the spicy ones.
You wish it was that easy. Oh, yeah. Mom, I have bad news. I ate all their fries instinctually. Mary handed it to me. I just swallowed all of them. Did you just try to open a drawer? Open it. Okay, before he breaks the drawer.
Good evening, folks. How's everybody doing tonight? Okay, that's good. Must be 6 o'clock. I hear the church bells ringing outside, so we might as well get started. See how we're doing on head count tonight. That's not bad. We got 21 out of 24. I don't know where the other three are. Maybe they've dropped the course without telling us. Okay, let me look at my notes here about what this class is doing next. Okay, it looks to me like we're going to begin and talk about state machines tonight. I don't know if that's what it's called in the documentation, finite automaton, maybe. And we'll continue a little of that into next week. And then on Monday night, we will be picking up some miscellaneous components and concepts that we need for after the exam to start working on our first microprocessors, understanding its design. We also, on Monday the 18th, are going to have that practice exam. I told you about that, right? Give me a green circle if you remember me talking about the practice exam. Okay, good. Yeah, I don't expect it to take us long to do. The biggest mistake people make is not following my instructions to the letter, and they submit something that can't be auto-graded. And auto grading is a good thing. So you don't want to be hand graded if the auto grader can do it, because they'll tend to find more things wrong. Then on Wednesday next week, we'll get everything done with that. We'll also probably talk about VHDL, which is a programming language for hardware as opposed to for software. And then I believe I said on the 21st, that Thursday night, we may throw together kind of an ad hoc review session. And that, of course, no extra credit for being there. Don't lose any points if you're not. But you might want to just get some questions answered about things that you're unclear about. Make sure before that you've done some studying, because the next class after that, which is Monday the 25th, we actually have the first exam. And that'll be really the first time to get your name on the board and, kind of show what you can do. I expect good grades just because of the general membership of the class and my chat. I go through and look at your all's records to make sure that nobody in here shouldn't be in here. And everybody that's in here, at least on paper, should be here. So, you'll want to make sure you do really well on that exam. It counts quite a bit too, as I recall. Let me see if we got that written down somewhere. Yeah, the exams, first two are 20% of your grade. So it'll count either 5 or 10% of this number, depending on how you do on the next exam. And then, of course, the final exam counts very heavy. What a lot of you are missing in is right here. You either haven't turned in homework or you haven't participated. We haven't had any labs yet. Those are all hardware labs we have in the last, let's see, where's the schedule here? In this section right here. But yeah, you want to make sure you do really well on this we can't even call it a midterm. It's not really a midterm. It's going to be kind of our transition from theory into practice. And we'll have covered at that point combinational and sequential logic and a lot of the pieces of equipment in terms of the electronics and concepts having around those that we need to implement a fully functioning CPU. Now, the fully functioning CPU won't be very smart, but it will do everything a CPU needs to do in its most basic form. So I'm looking forward to that with you guys, see how you do with that. Anybody have any questions about the procedural stuff over the next few classes? Okay, that looks like it. Okay, everybody give me a red circle so I can see who's here that's just pretending to be here. Okay, we don't know about Peter yet. Peter, are you there? If you are, give us a red circle. Generally, what I do is if you've disappeared a few times, it could be that you have broken equipment. I will disconnect you from the session, and then it'll be up to you to get back on the session. But if you're just hiding out somewhere and pretending like you're here, you won't be getting back on. Okay, let us get it moving ahead here. What do we call it formally? We call ourselves talking about finite state machines, session number 1. Okay, I can do that. I'm going to start a little ways away from specifically addressing the finite state machine. And I'm going to talk about D flip-flops for a second. D flip-flops have a fairly simple truth table to them. But if you remember, the truth table for flip-flops is going to be one whereby we really are talking about something sequential, because it doesn't happen until the next clock in the case of a flip-flop. Now, does it happen on the rising edge or the falling edge? Somebody stick your hand up and tell me. Mohammed, what do you think?
Professor, is it rising edge?
That's for a D flip-flop or for flip-flops in general?
Think flip-flops in general. It really depends. If you have a dot in front of a clock, then it's a lower edge. If
Okay,
not,
absolutely.
yeah.
Remember that the only time that doesn't apply is if we're using JK flip-flops. And the JK flip-flops we will use will always, unless I tell you otherwise, will always be making their transition on a falling edge. So Ds and Ts by default are on the rising edge unless we show the clock in a picture going the other way. But we'll pretend for now that the clock means the clock occurs as opposed to anything fancy about it. So the D flip-flop kind of says, I have D. What's the next value of Q going to be if D is a 0 and the clock occurs? Put your hand up if you can answer that. Okay, Michael.
Q would be 0.
Okay. And while I've got you here, what if it's a 1? What will Q be?
Q would be a 1.
Okay, good, excellent. So in terms of the D flip-flop, just in its simplest state, we can say that the flip-flop, if we set D to 0, Q matches what D was on the next clock. Now we can expand this table just a bit. Let's say we have D, and we have the current value of Q. So this is a D, the current value is a 0. We have D as a 1, the current value is a 1. D is a 1, the current value is a Q, Q is a 0. Or we have both of them being 1. So again, Q next is fairly simple. Who wants to give me the 4 numbers I need to write down here? Sargon?
Professor 0, 0, 1, 1.
0, 0, 1, 1. Okay, now what's interesting here is if you notice, it doesn't matter what Q currently is with the D flip-flop. All that matters is on the clock, whatever D is, it will get transferred through to the Q. So Q will change on the clock from Q to Q next. Of course, Q next now becomes the Q for the next time we see a clock. Anybody have any questions about those two tables? The first one's really a truth table, but so is the second one. They're just two ways of expressing the same idea. Robert, do you have a question? Or is your hand just up in the air?
Hand was just up in the air, Professor.
That's fine. That's fine. By the way, some of you guys will appreciate this because you very well may be this guy in your future sometime. Last night, I met with one of my former students. He is changing jobs, and basically we met to go over his resume. He had worked for me at one point along the way in his career, and then he had worked for many years with another company, and what he wanted was just basically some advice about the resume he was going to submit. No, he's going to get the job. I mean, he's very, very smart. But what I thought was kind of interesting about it is he's 44 years old, and he took this class when he was 18. And thinking about you guys, some of you guys are, probably 18, 19, 20 in that range somewhere. 24 years from now, you may still be looking to, make contact with me to, get some polish on your resume or do something getting ahead. Relationships and contacts you make are the most important thing you can do in computer science, well, in jobs in general, but particularly in computer science. You don't get jobs from resumes. You don't get jobs from fancy cover letters. You get jobs from who you know, who recommends you. And I can go all the way back to my college years. When I was in college and the time right after I was in college, one of the things I did was I played trombone. And anytime I wanted to play, I could play and make money because I knew lots of people in the business. I played the trombone very well. I wasn't the best player in the world, but didn't have to be. I was very dependable. I could sight read anything, and I didn't need rehearsals. That was the ideal trifecta for people needing a trombone player at the last minute. It's the same deal. Who you know mattered. If I just had this fancy written up thing that had said, I played at Juilliard or I'd played here or there, nobody would have ever looked at that. They knew me. They knew I could pick up the horn and I could play whatever they're going to put in front of me as soon as they laid it down in front of me. Computer science is the same. Learn who the people are around you that are important, get to know them, also get to know the people who know those people. I made a recommendation to a student one time. He was all flustered about he couldn't get a job when he got out of college. And I asked him one thing, well, hey, who have you told that you need a job? I said, did you tell your dentist? Did you tell, your XYZ, whoever they were? And no, he hadn't done any of that. He'd filled out, a couple of resumes, submitted them, and gotten back things that didn't go anywhere. Well, turns out his dentist had a person who worked for him who was a computer person who needed an employee. And they managed to get combined, put together, and made a, good career out of getting started with that job. So, don't be afraid to meet people in the field. If you're a really shy, heads down programmer, you still have to do it, even though you may be uncomfortable with it. Doesn't mean you have to be a party guy or a party gal. It just means that you have to be willing to let people know who you are and what you're capable of don't oversell yourself ever. That would be a terrible thing to do. But, that I've found many, many times that really if I introduce somebody, and of course, a lot of people know me in the business, but if I introduce somebody, quite often they get the job. Now, that doesn't mean if you came to me, I would introduce you. I might not think you're not worth it. I might not think you have gotten the chops yet to be able to do a particular job. And I wouldn't put you in a place or wouldn't recommend you for a place where I thought you'd fail. That's bad for me as well as bad for them and bad for you. But, those matches have been made. So that's one of the things you want to do as you go through school, make contacts with other students in the class. I know that's hard to do with COVID, but, does Samir know Menotti? Does Dante know Peter? Well, Peter may not be. Peter, are you here yet? I guess he's still not here. Okay. Anybody have any questions or comments before we go on? Everybody understands the truth tables we worked out here. Okay, let's do a T flip-flop. T and Q, next. T could be a 0. T can be a 1. What is Q next going to be if T is a 0? Menotti?
Would it be a 1?
Well, you tell me. Is it a 1?
I'm not sure, but I think so.
Okay, we'll write a 1 down. Anybody want to make that anything else? Anybody voting for 0 or something else? Robert, do you have something?
Yeah, we have no idea because we need to know what Q was because a T toggles Q.
Okay, so if T is not
Then it would
doing
be
anything,
current Q.
the current Q. So we could just put Q there.
And then for 1 would be not Q.
And that would be the inversion of Q. So we'll have to abbreviate with an exclamation point here. Okay, so that table is not as newsy as the one that actually says what T is, what Q is, and what Q next is going to be. That's why we have that second form to use for flip-flops. We know that it could be 0 and 0. It could be 0 and 1. It could be 1 and 0. And 1 and 1. So, Scott, what's Q next going to be if T is a 0 and Q is a 0?
It's going to be a 0.
Okay, well, I've got you. What's it going to be if Q is a 1?
It'll be a 1.
Okay, and let's see, who do I want to call on here? Dante. What's going to happen in this case? If T is a 1, Q is a 0.
Wouldn't Q next still be a 1?
What's a 0 right now? And it says toggle it.
Oh, it's total. Oh, so yeah, it would be
What's not
0.
2? It has to be a 1. Okay, so if it says toggle it and it's currently a 1, that means it will wind up a 0. That's kind of a way we can talk about flip-flop. Let me draw a little line here to separate these for the moment. We'll come back to that in a minute. Let me do it again. Now, we could do the same thing for RS latches, but typically with an RS latch, we're just not going to use those. We're not going to find them in the first place. They're going to be more expensive hardware. And the D's and the Q's and the D's and the T's and the JKs are going to be better for our use. So let's talk about the JK flip-flop. We have J, we have K. And let's just skip over the regular table and just jump right straight to the one that has Q here. And what we're looking to see is what Q next is going to be. Because we have 3 inputs, there's going to be 8 entries in our truth table. Put some spaces here. See how I'm getting prepared? I feel like a Boy Scout there all of a sudden. Okay, so look at each of these conditions and think about what Q next is going to be. And just kind of work it out, maybe on a little piece of paper off to the side somewhere. Okay, in the first case, we really have 2 cases which both have J and K set to 0. Let's see who's got their hand up there. Scott, what's going to be the values for those 2 rows?
0 and 0.
It means don't change. That's what the J and K both being low like that mean.
Sorry, 0 and 1.
0 and 1. Okay, let me actually, I didn't do it here, but I'm going to push these over a little so they're easier to read. Okay, the next guy, J is a 0 in both cases, K is a 1 in both cases, and then we have both conditions of what Q used to be and what it's going to be now. So, Herme.
Both would be 0.
And the reason is because J, when they're different, is always carried through to Q. Okay, now they're both different for the next 2 rows. Mikhail?
Both will be 1.
That's right. Both will be a 1 in this case. And Jay, how about these 2?
It will be 1 and 0.
Right, a 1 here because it's going to toggle. Okay, so that's the truth table. We could have written the other one down. I mean, we can stick it in here just for completeness. But we basically are saying we know what J is, we know what K is, we know what, or we're trying to compute what Q next is. And our choices, of course, are 0, 0, 0, 1, 1, 0, and 1, 1. We know that if we make it 0, 0, it will remain the same. Oops, that's not the Q key, though. It will remain the same. If they're different, but J is a 0, Q is a 0. If they're different and J is a 1, they're going to be a 1. Otherwise, we're going to get a toggle, which is not Q. Stretch this up a little bit there. So while this table is useful, kind of, the more useful table is when we expand it to contain all of the elements. Now, when we look at these, one of the things we want to consider is if we wanted to control, and we'll start with the D flip-flops. If we want to control what the next value of Q is, we need to be able to set D to a value that will force it to be the value we want. So really kind of the truth table, it's a very simple table, but we need is there's two inputs. There's Q and there's Q next. And the output is what we really need to do to cause that to happen. So what we would have to say here is D is our output. Now this is an easy one because Q can be a 0. Q next can be a 0. It can be a 0 and a 1 and a 0, or a 1 and a 1. So in order to make that situation occur, somebody read me down the 4 numbers I need to put down the thing here under the D. I'm basically turning this table inside out. Stephen?
Is it 0, 1, 0, 1?
Yes. Now, these tables up here, both of the two up here are called truth tables. This table, based on one of the truth tables, is called an excitation table. When it describes how you get an output to change from one value to another, we call that an excitation table. Let's do the same thing for a T flip-flop. First of all, what are the headings I need to write down for the T flip-flop for its excitation table? What do we consider the inputs of the excitation table? Here was the one we used for a J or for a D flip-flop. Jay, you again.
Is it Q and Q next?
Yep, it'll be Q and Q next. What'll the third thing be, the output variable?
It will be T.
Yeah, very good. And again, we have 0, 0, 0, 1, 1, 0, and 1, 1. So if we have our Q and Q next, arranged so that we're currently a 0, and we want our output to become a 0, what does T have to be? Argan?
0.
If it's currently a 0 and we want it to become a 1, Arme?
1.
Oops, shouldn't hit that key. Don't know. I have no idea what I just did. I do know this is the 1. Oh, this was a 0. I'm sorry. I'm typing on top of the numbers. It's currently a 1 and we want it to be a 0. What does it have to be? Nazu?
It has to be 1.
And finally, it's a 1 right now and we want it to stay a 1. Scott?
0.
You betcha. Okay, so one of the interesting things to note is that when you use a D flip-flop, the output's exactly whatever D is, no matter what Q was. Not true of a T flip-flop, which is the other single input one we have. Now, what do I call this particular table? What would I call this? Robert?
That'd be the excitation table for a T flip
Right,
flop.
the excitation table. We'll copy that down there. Of course, this guy is his truth table. Both of them really are, but we'll use that one first. So we know for this guy, here's a truth table. We need an excitation table. Aren't you excited now? So what are the headings of our columns in our excitation table going to be? Patricia?
Q, Q next, J, and K.
Okay, well, Q and Q next are the inputs. Then the numbers we need to know about then are what are the two inputs, J and K, have to be in order to make Q go from there to another number. It can go from 0 to 0, 0 to 1, 1 to 0, or 1 to 1. Now, this is a little harder to do, but you guys are up for it. So on a little piece of paper off to the side there, figure out what J and K have to be under both of those circumstances. Okay, well, let's kind of think about the possibilities we have. And let's think of them in terms of J and K having values. If J and K were both 0, which of these lines could happen? I'm actually going to open up some extra lines in here in case multiple things can cause things to happen. So what does J and K both being 0 mean, Stephen?
That it's what it. It's Q, right? The answer is always Q or something.
And if J and K are both zeros in a JK flip-flop, what does that mean, Yan Wen?
Okay.
It means Q equals Q next.
Right. So that means that 0, 0 would apply to this line and the bottom line. Is that right? Because if J and K are set to 0 and Q was a 0, it remains a 0. If it was a 1, it remains a 1. Am I correct, Matthew? Is that correct?
Yes. Yes,
Okay.
that's correct.
Okay, what if J and K are a 0 and a 1?
Because you said it's not.
It could be 0 Q and Q next 0.
Okay, so you're saying I can write myself a 0 and a 1 right here.
Yes, that is correct.
Anywhere else?
From my notes, no, but I can double check as well.
Okay, while he's checking, anybody else want to take a shot? Robert?
The 1, 0. Q1, Q next 0.
Okay, so what does it say when J and K are like this? It says the outcome of Q is
J.
always 0. Which is this row again, like you say. So we know that 0 and 1 can appear here. But what if it's a 1 and a 0? Matthew, you want to give that a shot?
Yes, that would be Q0 and Q next 1.
So that's this guy right here. Is there anything else?
And then Q1 and Q next 1.
For the bottom row you're saying down here? So when J is a 1 and K is a 0, we expect Q at the end of that to become a 1, regardless of what it was now. And that would be those two rows. So one more combination. What happens if we have 1 and 1 for J and K?
Oh no.
Namulin?
Q0, Q next 1, as well as Q1 and Q next 0.
So it's these two right here. And why is that the case?
Because when J and K are both high, it goes into toggle mode.
Right, it's toggle mode. Okay. So here is our excitation table, but we normally won't write it this way. What we'll do is we'll notice that for this to occur, we need J to be a 0, and we don't care what K is. So we could write it as having an X in this position. And I'll get rid of this row. For this to occur, we need J to be a 1, and we don't care what K is. For this to be the case, we need K to be a 1, and we don't care what J is. For 1 and 1 to occur, 1 goes to 1, we need K to be a 0, but we don't care what this guy is. So that's the truth table we would use for a J, or excitation table we'd use for a JK flip-flop. All we did is collapse the things that didn't matter. Okay, now we're not used to looking at it like that. We've kind of turned the table inside out. But I don't think it's going to be as hard to look at as you might think it is once we start using it. Now, fortunately for us, although you probably wrote these down as we went,
Oh, hey, wait, okay.
if you go to this web page and bookmark it,
I won't be able to. Oh,
you'll find this table. This table was written on October 5th, 2004 by Terry LaFrance, who was one of my better students at the time and took it to himself to actually write out the truth tables and excitation tables for all the types of flip-flops. We only care about the last three. And over here on the right is the thing we're most concerned with in these is what is the excitation table for a particular flip-flop. Now, you have no idea why we're going to use them yet, but you do know that we now have a way to power a cue from whatever it is to something else predictably by setting the input of a flip-flop and waiting for a clock. Part of the sequential nature of a flip-flop. We're talking about what happens next quite a bit. So you might want to get a copy of this. I have a copy printed out that I keep near me because I don't want to compute those every time I do work a problem. But also, if you bookmark it, you can get to it quite easily online. And you'll be able to go to any of the handouts I've given you during the exam. They'll be legal. So anybody have any questions about this? Now, I think there's actually a typo inside the RS latch somewhere, but don't worry about it because we don't have any and are not going to use any. But if he did, we'll forgive him. And if you double check what we did with his chart, make sure it's the same. It was nice of him. He was worth thinking about the people happening years and years. That's almost 20 years ago that he did this for the class. And every semester, everybody's benefited from it. Anybody have any questions yet about how to derive an excitation table? If I gave you some other type of flip-flop, you'd be able to write down its truth table. Well, yeah, I probably have explained it to you in terms of a truth table, but you'd be able to turn that into an excitation table. Give me a green circle if you believe you could do that. Okay, Peter, are you there? Let me refresh his thing. If you're there, you're going to need to relog